Today's lesson is on solving compound inequalities. In our first type of compound inequality, it's the AND inequality, in which case there's two things going on at the same time. Both of them need to be true when solving this. So number 1 says negative 2 is less than or equal to 3x minus 8, which is less than 10. What that means is negative 2 is less than or equal to 3x minus 8, while at the same time 3x minus 8 is less than 10. Now, different teachers show different ways to solve this compound inequality. I like to break this up into what I call 3 sections. So I draw lines, kind of like my wall, at the inequality signs, and I'm trying to isolate my variable in the center. So the first thing I'm going to do to get that x by itself is I'm going to add 8 to both sides. And I have 6 is less than or equal to 3x, which is less than 18. Now from here, I'm going to divide by 3. Again, to isolate my variable. Whatever I do to one section, I have to do the other sections. And I have 2 is less than or equal to x, which is less than 6. Now let's get a little visual on that. Here's 2, 2, 3, 4, 5, 6. So I have a closed circle above 2. 2 could be a solution. And I have an open circle above 6. So anything between 2 and 6, including 2, but not including 6, is a solution to this compound inequality. I like to say this one looks like a barbell when solving it. Moving on to our next inequality, we have the same idea. We have an AND statement here. So I have my 3 sections. I'm going to isolate my variable in the center. So I'm going to subtract 3. Whatever I do to one section, I need to do the other 2 sections. So I have negative 2 is less than 2x, which is less than or equal to 6. Divide everything by 2. I have negative 1 is less than x, which is also less than or equal to 3. There's my graph. There's 0 here, negative 1, and then 3. I have an open circle above negative 1 and a closed circle above positive 3. The barbell goes in the center, so solutions are any numbers between negative 1 and 3, not including negative 1, but including 3 as possible answers. In our next problem, we have the same idea. We have a compound inequality with an AND statement. I'm going to add 4 to both sides. And I have 0 is less than or equal to negative x, which is less than or equal to 5. Now in the center, I don't have positive x, I have negative x, and I need to make that into a positive x. So I'm going to divide everything by negative 1. Now I have to remember when I divide by a negative number, I change the direction of the sign. 0 divided by negative 1 is 0. I do have positive x in the center, which is what I wanted, and negative 5. Now, this is the solution to this compound inequality. When graphing it, it's a little easier if we have our number line matching up with our values. So negative 5 is actually to the left of 0, filling in my values. The inequality sign is pointing to my negative 5. It will continue to point to my negative 5. This sign right here is pointing to my x. It will continue to point my x. And that just makes it a little easier to graph. So here's negative 5 here, 0 here. This time I have closed circle because of the equal sign there. So my barbell is any values. My solution is any values between negative 5 and 0, and including those values. Now, we usually see this rewritten because it's a little easier to graph, and not only in a standardized test, a lot of times we do see the numbers in order as they appear on the number line, so the arrows will always be pointing to the left. Let's try one more with the AND inequality. So there's my wall. Add 4 to every section. I have positive 1 is less than or equal to negative x, which is less than or equal to 6. Again, I want positive x in the center, not negative x. So I'm going to divide everything by negative 1. Change the directions of the sign because I divided by a negative number. And I'm left with negative 1 is greater than or equal to x, which is greater than or equal to negative 6. So like we discussed in the last problem, we're going to rewrite. So I have negative 6 is less than or equal to x, which is less than or equal to negative 1. Sketch a graph. Negative 1 is here, negative 6 down here. Closed circle above each. Connect them, and the solutions to this compound inequality are any numbers between -6 and -1, including those values. The second type of compound inequality involves an or. So there's two statements going on at the same time, again, like the and statement. However, this time, both of them don't have to be true at the same time. One or the other will be true. So what I do with this or statement is I just solve these problems separately, solve the inequality. So on the left-hand side, where I have 5x plus 3 is less than -2, I'm simply going to isolate that variable like I have in the past. I have 5x is less than -5. Divide both sides by 5, and I have x is less than -1. Now I need to bring down that or symbol because that's one part of this compound inequality, and I'll solve the other part. 4x is greater than 16. Divide both sides by 4, and I have x is greater than 4. So my solution is x is less than -1 or x is greater than 4. Either of those can be true in order to receive a statement that will make this inequality true. So when I graph it, part of this compound inequality says x is less than -1, so I have open circle to the left. So all values that are less than -1 will make this compound inequality true. And I have x is greater than 4. So again, going in the opposite direction, one statement or the other statement can be true in order to solve this compound inequality. So our next compound inequality says -6x minus 5 is less than 7, or -8x plus 1 is greater than or equal to 25. So I'm going to solve them separately. So on the left-hand side, I'm going to add 5 to both sides. And I have -6x is less than 12. Divide both sides by -6, and I have x is greater than. Now remember, I need to change the direction of the sign because I divided by a negative number. So I have x is greater than -2. Bring down that or, and now I'll solve the right-hand side. So I have -8x plus 1 is greater than or equal to 25. Subtract 1 from either side. -8x is greater than or equal to 24. Divide both sides by -8. So now again, I divided by a negative number, so I need to change the direction of the sign. And I'm left with x is less than or equal to -3. Now when I graph that, there's my 0, -2, -3 here. So I have x is greater than -2, so I have an open circle to the right. And then I have x is less than or equal to -3, so it's a closed circle to the left. Now we're shifting gears a little bit. In the previous examples, we solved the compound inequality and then we graphed it. But on the next few problems, the directions say to write the inequality that describes the graph. So if I look at number 1, I have an open circle above -7 and a closed circle above -3. And my solutions are all in between. So I know that's an and compound inequality. So I'd like to set things up first. So I know -7 is on my one end, -3 is on the other end. I have an x, or really any variable in between. Now because I have an open circle, I know that needs to say -7 is less than x. And because above the -3 I have a closed circle, I know that I need a less than or equal to. So when I write this inequality, it's -7 is less than x, which is less than or equal to -3. And looking at number 2, I also have a compound inequality. I have a closed circle above -4 and a closed circle above +4. I can see that these graphs are going in opposite directions, so I know I'm going to have an or statement. So looking at the first part, I have x is less than or equal to -4, or, because I have another alternative, my other part of my answer is x is greater than or equal to +4. So my compound inequality says x is less than or equal to -4, or x is greater than or equal to +4. In our last two problems for today, if we look at number 3, I have an or. I have two things going in opposite directions. So I have a closed circle at -1, an open circle at +1, and again arrows going in opposite direction. So the first part of this inequality is going to say x is less than or equal to -1. There's my or. X is greater than +1. So I have x is less than or equal to -1, or x is greater than +1. And then the last one, number 4, I have a closed circle above -4, a closed circle above 0, and my solutions all fall in between. So let me just get it set up. I have -4, and then I have x in the center, 0 on the right. They're both solid, circles there, they're filled in, so I know I have -4 is less than or equal to x, which is less than or equal to 0.